This is Algebra 2 with Trig 8D.1. We're going to talk about graphing the basics of sine and cosine. And this is all from the unit circle. So these types of graphs, we call them periodic functions. And it's a function for which the outputs repeat at regular intervals. So the graph is going to continue on forever. And it's possible to slide the graph over on top of itself. It just repeats itself again and again. When a function is periodic, the function is going to equal a function that's been translated. That would be notation of showing our translation. We typically would talk about x minus h, but in this notation they're using plus p. For some of the real numbers p. This means that for every p units, the function's outputs repeat themselves. The smallest such values of p is called the period. Okay, the period is the angle values. It's the x values that it takes to repeat. Let's make a table of values to determine the graph of y equals sine of theta. So a lot of times we say sine of x, but here we're just using a different notation with sine of theta, and we'll be able to see what that looks like. Because theta is an angle measurement, we're not going to use -2, -1, 0, 1, and 2 like we have in so many other type graphs we've done in the past. We're going to use our special values for theta that we find on the unit circle. So down here is a unit circle. Here's a little sketch of a unit circle. We're going to talk about the values for sine. So we're talking about the y values. What is the y value on the unit circle? Thinking about the coordinate, what is the y value at 0 degrees? The x value would be 1, because that'd be 1 over. The y value would be 0. At pi over 6, what would the y value be? Thinking about your coordinate, I just think about it as long, short. What's that value going to be? It's going to be a half. At pi over 4, what's our coordinate going to be for the y? Root 2 over 2. At pi over 3, what's the y value? Root 3 over 2. Then at 90 degrees, otherwise known as pi over 2, we would be 0 for x and 1 for y. So what's the y value? 1. And then we start to come back down. At 2 pi over 3, we're up high, so that's root 3 over 2. At 3 pi over 4, we're at root 2 over 2. At 5 pi over 6, the y value is a half. And at pi, this is -1 for the x and 0 for the y. That would be 0. And then we would just continue around. We get to 7 pi over 6. That's a short distance down, so that's -1/2. And negative root 2 over 2. Then I've come through and filled in the rest for you. At 4 pi over 3, would be down a long way, would be at -1, negative root 3 over 2, negative root 2, -1/2, and back to 0. Now watch what happens. After you complete a full circle, the graph starts to repeat itself. We're back to a half. And then root 2 over 2, root 3 over 2, to 1. And it would just continue that pattern on. So down here, I have plotted all of those points for us. At 0, degrees, I've plotted a 0, because that's what the y value was at 0 degrees. At pi over 6, I plotted a half. That would be up near 0.5. At what approximately would be pi over 4, I plotted our point. And at pi over 6, I plotted our root 3 over 2. And then we reach a maximum value of 1. And we just keep coming all the way through and plot all the points like we've had on here. Here's our x, here's our y. Here's our x, here's our y. So notice what this graph is doing. For one thing, it's not pointy. It curves, it rolls. Following all those points, it curves through there. Now it does repeat itself. So we'd be here, and then the graph would repeat itself as it keeps going to the right, as the angle keeps getting longer. We typically will only graph one of these cycles, one set of the graph that is going through the full maximum minimal roll of the periodic function. This means the period, because it took from 0 up to 2 pi before it repeated itself, that means the period is considered 2 pi. So, on the flip side, we're graphing out cosine. So if we kind of look at our thought of a unit circle, or you can physically look at your unit circle down here, I filled in all the points for us already. At 0 degrees, can you focus on the unit circle where 0 degrees is at? That would be over here. And that coordinate. Cosine graph is focusing on the x values. So at 0 degrees, we're at a height of 1. At pi over 6, not a height of 1, I said that wrong. It would have been like a distance. It's to the x value of 1. This is the x value of root 3 over 2, x value of root 2 over 2. At 60 degrees, we're at an x value of a half. It's a short distance over and a long way up. So the short distance over is your x. At pi over 2, we're at 0. 0 right and left. The y value is 1, but the x value is 0. And then you continue left, a half, root 2 over 2, root 3 over 2, and then at negative 1. And you continue in the third quadrant, and then fourth quadrant. So you would get values that look like this. Notice where this cosine graph crosses the y-axis. Why would it cross up here at 1? This is 0 degrees. The y-axis is 0 degrees. And what happens at 0 degrees? The x value is 1. That's why the graph of cosine is 1. When the angle is 0. And at pi over 2, we're at 0. At pi, we're at negative 1. Root 3 over 2, we're at 0. And at 2 pi, we're back at 1.
Is the x-value on the graph the value of theta in the circle?
So notice that the y values begin to repeat themselves when they're way over here. They repeat themselves when theta is 2 pi. So that tells us that the period of the function f of theta equals cosine theta, the period of that is 2 pi. Because that's how long it takes it to repeat itself. Now down here we have a Desmos little activity. See if I can demonstrate that here. Alright, so we're moving around our circle, and notice that the height is changing as the dot goes around the circle. Okay? So here it's at -1, then it comes up there at 1, and we can start to graph that through. And you watch at the height that it is, that's the value that it's sitting at. So at pi, we're back at 0. Straight down, we're at 3 pi over 2, we're at -1, and it repeats itself throughout. It's a periodic graph.
Did you use it a lot during your overview?
All right, here's some definitions. A midline. A midline is a horizontal line halfway between the maximum and the minimum points. So here, our midline would be right there. So I'm going to draw a dark line through here. And that is our midline. That midline is always going to be halfway between the minimum and the maximum. It can change. It may not be the x-axis. Right now it's always the x-axis because the graph is as basic as it gets, is the parent function. If we had some translations to it, that midline could change, and that'll take the maximum values up, and that'll bring the minimum values up with it, that same amount. The amplitude of a graph is half the distance of the maximum and the minimum. It can also be considered the distance from the midline to any maximum point or minimum point. So coming on back, this would be an amplitude, abbreviated AMP. This would be our amplitude also. That would be an amplitude. It's the distance from the midline to the max or the min. Amplitude is always a positive value. That's a common mistake. Amplitude is the distance. It's always in the distance that it takes to get to the minimum should be the same distance that it takes to get to the maximum. Okay, different characteristics about the sine and cosine graph. The domain of each of our functions. Well, when we were over here, the domain, we talked about how the graph hit each one of these points as it went through. That shows you that it's not real pointy. It doesn't point at any, it's not a V shape. So try to make yours curved when you start to draw some. But it's going to continue on. And on this side it would come through and continue on as well. That's what makes it periodic. It continues on and it repeats the same pattern. So that's telling us that the domain, which are your angles, they are all real numbers. Because you can plug in any angle value for cosine of x, and you can figure out what the y value would be. That would be just thinking about your unit circle, and if you went 300 degrees, you could figure out what your x value is. If you went 720 degrees, you could figure out what your x value is. If you went 1,000 degrees, you could figure out what your x value would be. The range of the function. The range, looking back at our graph, range is a y value. It has a minimum. It has a maximum. So the range is from -1 all the way up to +1. That's assuming that the amplitude is not changed. The amplitude is your a value of the graph. It's going to be 1. It's the value in front of your sine. So as long as we're just doing sine of x or cosine of x, the range is going to be from -1 to +1. The midline will be at x equals 0 unless there's a translation, unless it's been slid up or down, depending on what your k value is. The amplitude is that a value, like I mentioned. It'll be a value that's in front of sine, so it might say 3 sine of x. That tells you that the graph is going to reach up higher than normal. And the period of each function is the value of theta. Period is a theta value. It's an angle answer. The period is an angle that it takes until you repeat. So when we look back here, we're starting at 0. And it takes until we get here for it to do the same repetition again. So that was 2 pi. That's the period of the parent function. So let's try some of these. Find the period and the amplitude of our function. Here's the function that we're working with now. First of all, do you think this is similar to sine graph, or do you think this is similar to the cosine graph? Take a look at them. Here is what the cosine graph looks like. It's starting off the midline, and then our sine graph starts on the midline and finishes on the midline. So when I look at this one, I notice that we're starting at a maximum, and we go all the way through the graph, and we finish at a maximum. Then we just do it again, and again, and again, and again, and again. So we would typically say that this looks like a cosine graph. But if you just slide back here a little bit, you could say that you're starting on the midline and then you're finishing on the midline. So you can write an equation that's cosine for this, and you can write an equation that's sine for this. But the sine graph is going to have more translations to it than the cosine graph will, because the cosine graph has a maximum on the y-axis, and it starts to repeat at its maximum point. So that's why we would want to call it cosine. What is the period? What is the angle value that it's taking for this graph to go from a maximum to a maximum? This is at 0, so this would be 1 pi. It's not at the maximum yet. 2 pi, we're actually at the minimum. 3 pi, we're back at 0. 4 pi, hey, I'm up here. I went through the whole graph, and it took me until an angle value of 4 pi to reach that maximum value again. And then I'm going to repeat 4 pi again until I reach it. 4 pi again, 4 pi again. So my period is considered 4 pi, because that's the angle that it takes to get from a maximum to a maximum. Now, if you want to get crafty, you can start here at 0. And for you to go from 0 all the way back to increasing through 0 again, that is going to be 1 pi, 2 pi, 3 pi, 4 pi. It's going to be the same period. Or from minimum to minimum, if you want to recognize your graph there. Your graph is going through this cycle. The cycle is the path of the graph. Typically we graph one cycle, and that would be 1 pi, 2 pi, 3 pi, 4 pi. Next we have the amplitude. Now, what's our amplitude when we look at this? Our amplitude is from the midline to the maximum, or the midline to the minimum, the midline to the maximum. It is a distance of 3. In the future, we'll see just how this works out on an equation. All right. So this next one, what type of graph does this look like? What does it imitate when you first look at it? It's starting from the x-axis. When we look at the y-axis, it's crossing at the x-axis. When we were at this one, we look at the y-axis, it's crossing at the maximum on the y-axis. So that's why we call this cosine. This is crossing at the midline. It goes up and then it goes below. So we would want to call this a sine graph. But there are arguments that if you wanted to translate over a little bit, there's your maximum point, and then you could be looking here at this portion. It's called the cycle. And you can get all your data that you need right from that information. But we'll primarily look from 0 until it reaches 0 again. Don't get confused on this being 0. This is decreasing through 0, but here we are increasing through 0. So we're increasing, decreasing, and increasing. So that's our cycle. So our cycle would be right through there. And then that would repeat itself again and again and again as it went through. So that's why we call it sine. What's the period? What is the x value that represents how far the cycle travels to the right? Okay, this is 1, this is 2, this is 3, this is 4. We're not going to throw pi's in there. We'll just call it 4. And what do these numbers even mean? Because we don't typically use those numbers. 3.14 would be pi. And 6.28 would be 2 pi. So here they're just using numbers like 1, 2, 3, and 4. These increments have removed the pi from them. Because it goes from 0 over to 4 and then starts to repeat itself, that would be called a period of 4. What's our amplitude? Everyone should have an opinion. We are looking from the midline up to the maximum point, or the midline to the minimum point. Doesn't matter which ones of these we look at. You could even take the maximum value, which is 2, minus the minimum value, which is negative 2, and you divide that by 2 or multiply that by a half. So we're going to get 2 plus 2 is 4 divided by 2, which is 2. That seems pretty complicated. Just look to see that it's 2 steps up. So the amplitude is 2.